Assalamualaikum warahmatullahi wabarakatuh. So we are from Group 6. So today we are going to present our title group project, which is the title is Application of First and Second Order Linear Differential Equation in Electrical Field. So we are going to the next page. So this is our group team's member, which is the first 3% is myself, Muhammad Salahuddin Abdul Salam, and then the other person is Muhammad Nazran, and then Muhammad Zarif. Then for the other last 2% is Muhammad Nazir and Siti Noh Natra. So we are going to next page. For the introduction of this title project, a first order linear differential equation is a differential equation of the form of y plus pxq equal to qx, y plus pxy equal to qx. The left hand side of this equation looks almost like the result of using the product rule. So we solve the equation by multiplying through by a factor that will make the left hand side exactly the result of a product rule, and the integrating this factor is called an integrating factor. First order linear differential equation are the only differential equation that can be solved even with variable coefficient. Almost every other kind of equation that can be solved explicitly requires the coefficient to be constant, making this one of the broadest classes of differential equation that can be solved. Then the second order linear differential equation with variable coefficient are differential equation whose coefficients are a function of a certain variable. A second order linear differential equation has a general form where P, Q and R are functions of the independent variable x. If P and Q are some constant quantities, then the above equation is known as a second order linear differential equation with constant coefficient. If R equal to 0, then the equation is called a homogeneous linear differential equation of second order. Otherwise, it is non-homogeneous. Then we are going to the next slide. Then for the next page, we are going to the objective and the problem of statement for this project. The objective of this project is, the first one is implementing of first and second order linear differential equation method in engineering field. The second is utilize mathematical analysis to understand the underlying principle of engineering system. The problem statement is, we were given 4 questions for our project. The first of 2 questions is the first order linear differential equation, and the last 2 questions is second order linear differential equation. The first is, this typically involve finding a solution that satisfies certain initial boundary condition. A first order differential equation has the general form, which is dy over dx plus pxy over equal qx, where y is the unknown functions, x is the independent variable, ps and qs are given functions of x. The problem statement usually specifies additional information such as initial conditions, which can be of the form y(x0) equal y0. This means that the function yx must satisfy the equation and the initial condition at the point x0, y0. And then for the second problem statement is second order linear differential equation. A second order linear differential equation has the form of d2y over dx2 plus ps dy over dx plus qxy equal to rx. Here, y is dependent variable, x is the independent variable. d2y over dx2 represents the second derivative of y with respect to x. dy over dx represents the first derivative of y with respect to x, and px, qx and rx are functions of x. To find specific solutions to these equations, initial condition or constraint need to be provided, such as specific value of y, dy over dx, d to y over dx2 at a given point. With those constraints, we can solve the differential equations using various methods like separation of variable, integrating factors, or by using specific techniques for second order linear differential equation, such as the characteristic equation method or the method of undetermined coefficients.
Assalamualaikum. Next is the application of the first order linear differential equation. Find the amount of the current in RC circuit at any time when initial current I equal to 0 and time equal to 0. Given circuit, RC circuit, as we can see, the power supply is 50 volt, the resistor is 10 kilo ohm, and the capacitor is 10 microfarad. So the formula is V equal to VR plus VC, and we change to V equal Ri plus 1 over C integrate I dt. So V equal R di over dt plus 1 over C I di over dt plus 1 over RC I equal to V. And then we change the formula to the question given. So we get the du over dt plus 100I equal 50. So next go to the Pt equal to 100, and Pt is a resistance. Next is Qt equal to 50. Qt is the voltage. So Vt equal E or exponent integrate 100 dt, and the answer is exponent 100t. Next, we integrate the exponent 100t I, and then we get the exponent 100i equal to exponent 100t over 2 plus c. Next, when t equals 0 and I equal to 0, exponent 100t I equal exponent 100t over 2 plus c, and then the final answer for the exponent 100t, we get c equal to negative 1 over 2. The next, exponent 100t I equal to exponent 100t over 2 minus 1 over 2. This is we differentiate the equation. So the answer after differentiate this equation, we get I equal to 1 over 2 in bracket 1 minus exponent negative power 100 of t at any time t equal to 15 seconds. So we take the equation again, I over 1 over 2 in bracket 1 minus exponent negative power of 100, and t we change to 15. So we get 1 over 2a or 0.5 a. A is equal to ampere. So for this RC circuit, we get 0.5 ampere. Next, I will pass to my friend.
To find the solution of linear solution, for the equation can be written as di over dt plus r over li equals to e over l. We can substitute the value of r, l, and e. So we get the answer is di over dt plus 32i equals to 72. So we represent Pt equals to 32 and Qt equals to 72. So for the convenience, the expression of Vt equals to E integrate 32 dt is integrating factor. So we integrate this integrating factor and we got the exponent 32 3 I equals to 9 exponent 32 t over 4 plus c. In this equation, we introduce a constant of integrating so that we need to find the value of c. So we substitute the time equals to 0 and I equals to 0. So we get the answer c equals to negative 9 over 4. So after we get the value of constant, We substitute the value of constant into answer of integrating factors, so we get the particular solution, that is I equals to 9 over 4 in bracket 1 minus exponent negative 32t, and at any time if t equals to 7 seconds, so we substitute the t in the equation, so we get the answer. The final answer of current is 2.25.
Ya, Assalamualaikum warahmatullahi wabarakatuh. So the next problem is, then there is second order linear differential equation. The question is, a circuit has EMF as ET equal to 170 volt and a resistor of 15 ohm, an inductor of 1 Henry, and a capacitor of 1 over 1900 F. If the initial current charge on a capacitor are both zero, find the charge on the capacitor at any time t. So first we have to list all the value, and there is ET equal to 170 volt and R equal to 15 ohm, L equal 1 H, C equal 1 over 1900 F. The initial given for this question is I0 equals 0 and Q0 equals 0. So next we must multiply the L and the d power by 2 Q over dt power by 2 plus R for resistor dq over dt plus 1 over C capacitor times with Q, and all the equation must equal with ET. So we insert the value. L equal to 1 times d power by 2 Q over dt power by 2 plus R equal to 15 power multiply with dq over dt plus 1 C equal to 1000 per over 1000 1 over 1 over per 1 over 1 per 1900 Q equal to 170 volt. So we after we multiply all the value, we have the non-homogeneous equation. So from this non-homogeneous equation, we must change it to homogeneous equation. So it turns like d double prime d power by 2 Q over dt power by 2 plus 15 dq over dt plus 1900 Q equal to 0. This is the homogeneous equation, and change it to be like this: m power by 2 plus 15 m plus 1900 equal to 0. So we get the value of m is negative 7.5 plus minus 42.939 I. So it means that the value of B is less than 4 AC. So we get the complex equation. So alpha equal to negative 7.5 and beta equal to 42.94. For the homogeneous equation, for the complex, QC equal to exponent power by 80 times A sin beta t plus B cos beta t. So we insert the value. For the QC equal to E exponent power by negative 7.5 t times A sine 42.940 plus b cos 42.940. Next, for the value of ft, is 170 volt, which means it's equal to ET. We must differentiate the value. So we get, for the first differentiate, we get QP over PQP equal to C, and the second differentiate, for the first differentiate, we get 0, and QP double prime, we have 0. After that, we insert the value into the equation 1, and that is m power by 2 plus 15 times m plus 1900. So we get, for the second order, we have 0, and the first order, we put the 0 and none. 1900 times by c equal to 170. So we solve this question. So we have c equal to 17 over 190. For the general solution, we have, for the formula of general solution, q equal to qc plus qp. So we insert the value e exponent power by negative 7.5t times a sine 42.940 plus b cos 42.940 and qp plus 70.190. This is equation 2. After that, we must find the value of a and b. Okay, for the next step, we must find the value of I, and here we have I equal to dq over dt. So I, we must differentiate the value of q, and that is dq over dt, and we get I equal to exponent power by negative 7.5t in bracket 42.94a cos 42.940 minus 42.94b sin 42.940 plus in bracket a sin 42.940 plus b cos 42.940 times with negative 7.5 e negative 7.5 exponent power by negative 7.5 t. Next, substitute q0 equal to 0. This is the initial equation from the question. Q0 equal to 0, insert to the equation 2. 0 equal to e exponent 0, a times 0, b equal to 1. After we solving the equation of q, that's why we have a0, b1 plus 17 over 190, and we solve the question, and we have b equal to negative 17 over 190. Next, we substitute I0 equals 0 into equation 3. So we get 0 exponent e power by 0, we get 1, and in bracket 42.94 a, we get 1, because if we insert the value of t, we have 0, and sine 0 cos 0, we get 1, and cos times 0, we have 0. That's why we have the value of 0 for this question, 42, and the same as up here, for the equation 2. Okay, continue. 0 equal to e power by exponent power by 0 in bracket 42.94 a 1 minus 42.94 b times 0 plus a times 0 plus b times 0 times negative 7.5 e exponent power by 0. After we solve this question, we get a equal to negative 1275 over 81,586. And after we have the both value a and b, so we insert the value into the equation of q, the general solution. So we get e negative 7.5t in bracket a is negative 1,275 over 81,586 sine 42.940, and the value of b is negative 70 and over 190 times cos 42.940, and QC is plus 17 over 190. Okay, that's all from me. Thank you.
Okay, for the next part of second order linear differential equation, consider a series RLC circuit with a resistor, an inductor, and a capacitor, which are represented by RLC respectively, connected in series. The current through the circuit is governed by the second order differential equation. Okay, the equation which is L times d square L over dt square plus R times dL over dt plus L times 1 over C equals to 0. Okay, where function L t represents the current as a function of time, which is t. This equation is derived from the Kirchhoff voltage law. Okay, question A, solve the differential equation above to find the general solution for function Lt. Question B, if the values of R, L and C are given as 100 ohm, 0.5 H and 10 microfarad respectively, and the initial conditions are function L0 equals to 1A and dL over dt 0 equals to 0 A per second. Find the particular solution for function Lt in this circuit. Okay, for the solutions for question A, given function L times d square L over dt square plus R times dL over dt plus L times 1 over C equals 0. To find the general solution for function Lt, we assume a solution of the form Lt equals to exponential Rt, ERT, where R is a constant to be determined. Taking the first and second derivative of assumed function Lt with respect to time, we have dL over dt, which we can call L prime, equals to R e power of Rt. And next is d square L over dt square, which we can call L double prime, equals to R square e power Rt. Then substitute into the original differential equations. We get L times R square ERT plus R times R ERT plus 1 over C times ERT equals to 0. Then we factor out the e power of Rt. Factoring out ERT, bracket L times R square plus R bracket R plus 1 over C close bracket equals 0. Since e power of Rt will not equal to 0, the equation inside the parenthesis must equal 0. Therefore, we have the characteristic equation of L R square plus R plus 1 over C equals 0. Okay, for question B,
Okay, given R equals to 100 ohm, L equals to 0.5 H, and C equals to 10 microfarad. Initial conditions are L function L0 equals to 1A, dl over dt 0 equals to L prime 0 equals to 0A per second. Okay, the function L R square plus R plus 1 over C equals 0 is from our answer in A. Then we substitute in the given values of R, L and C into the equation. We get 0.5 times R square plus 100 times R plus 1 over 10 times 10 power of negative 6 equals to 0. Or we could also say 0.5 R square plus 100 R plus 10 power of 6 equals 0. Using quadratic formula, which is R equals to bracket negative B plus minus square root of B square minus 4AC over 2A. Substitute in the values into the quadratic formula, we get R equals to negative 100 plus minus square root of 100 square minus 4 times 0.5 times 10 power of 6 over 2 times 0.5. And then we calculate. We can put that into the calculator and we can get an imaginary number here, which is R equals to negative 100 plus minus 1412.45 I. So next, the general solution for function LT is given by L function T equals to A times e power of negative 100t times cos 1412.45t plus b times e power of negative 100t times sin 1412.45t. To find the particular solution, we'll use the given initial conditions, which are L function L0 equals to 1A, L prime 0 equals to 0A per second. Okay, substitute the initial condition into the general solution. We get A times E0 times cos 0 plus B times E power 0 times sin 0 equals to A equals to 1. Then for L prime 0 equals to negative 100A times E power 0 times sin 0 plus 1412.45 B times E power 0 times cos 0. We get 1412.45 B equals 0. We get B equals to 0. Therefore, the particular solution for LT in this circuit is LT equals E power of negative 100t. That's all from me. Thank you.
Then for the last part is conclusion. In conclusion, first and second order linear differential equation are fundamental mathematical tools used to model a wide range of physical, engineering and scientific phenomena. First order linear differential equations describe relationship between a dependent variable and its first derivative with respect to an independent variable. They are commonly used to study exponential growth or decay, as well as the behavior of circuits, chemical reaction, and other dynamic processes. Second order linear differential equations involve the second derivative of a dependent variable and can capture more complex dynamics and behaviors. They are often used to model oscillatory systems such as mechanical variations, electrical circuit with inductance and capacitance, and many other phenomena that exhibit periodic or oscillatory motions. So, that's all from us. Thank you.